Well, welcome everybody to this session. My name's Ian Rosen. I'm Director of Product Management for Civil Engineering, and I am really excited to take you through this session on civil workflows with digital twins and give you some insights into and background from the industry and from what we're trying to do to help the industry in this incredible time of change. So, as hopefully you're already aware, you know Bentley provides solutions for project delivery and asset performance across a wide range of different types of asset classes and infrastructure. Specifically, though, road, rail, bridge, substation, power plants, water treatment, and the like. You name it, and we seem to have a foot in the camp. We run the gambit across the board on a lot of different types of infrastructure, but to me, my background is civil, and that's where I like to be focused on transportation. So our roads and highway software, so everything for the stuff that we build with bridges, structures, rail and transit. And there's some others like ports and waterways that we get involved in, but basically anything involved in moving people and goods around the world is really where I like to focus, and Bentley are focused. No, I said exciting times, and I wasn't kidding. It's very exciting times. And if we look back at the last half century in the transportation sector, particularly for roads and highways and rail, and look at the technology and how it's evolved over the last sort of few decades, it has come on in leaps and bounds. We all started off in 2D. We know that back in the day, way before the sort of 90s. But it has transitioned through that time period, and what we're seeing from a technology standpoint through 2D into 3D, 2.5D and 3D, where we get the integration, starting to see the integration with web and cloud, and then potentially as we get into the virtual design and construction, we get much more 3D, and we see the introduction of BIM and smartphones and drone usage on site, through the sort of 2010s. And then here we are in this incredibly fast-paced moving world with what we call digital twins and cloud computing and the Internet of Things. But what's very evident as we look at the adoption of these different types of new technologies, yes, on the left-hand side, with the desktop client, with CAD, it's 100%. But it's a rapid fall-off as we go across. And this is where we're trying to see that adoption, and we're trying to help with that adoption of accepting the new technology and ramping up of that new technology. But we see with that, and it's all about digitalization, we see with that some significant challenges with the digital workflows. And what we see are things like inefficient design handover processes and the safety integration and making sure that we maintain as much uptime as we can in what are essentially very complex construction projects. We have to deal with environmental issues and potentially even workforce shortages, and obviously changing times in the last couple of years and changing workforce as well as to how we operate. But we also have to start looking from an advancement with that technology about predictability, especially with assets and when assets need to be maintained, and schedule simulation for construction and visualization associated with these complex 3D projects. And so that's really where we have to start looking at things like big data and how do we get project insights across that, and automation as well. So this is where we see going digital as being important. And we've been talking about going digital, certainly with Year in Infrastructure and with our messaging for many years, quite honestly, more than I'd like to sort of really remember at this point. But it's certainly about trying to improve productivity and profits and avoid cost overruns and increase modeling efficiency. Now, what we see with digital processes through ProjectWise is significant reductions in things like design costs through the use of using something like ProjectWise in a digital environment. And we see that coming with, say, AMEC Foster and and Wheeler, quoting their figures there. Improved modeling efficiency as we go into that 3D world, and that can be sort of associated with Longjian Road and Bridgeco, and then the California Highway State Rail Authority, a decrease in delivery time of 56% by using ProjectWise and digital processes. And then finally, the reduction in design errors across the board. This is a quote that comes from Shanghai New Jinzan Investment Holding Group in respect of their project. So some incredible digital saving processes that can be achieved. So going digital, it's not a new phenomenon. We've been talking about it, as I said, for years. And, well, one thing that I always like to draw out, we've all been on site. There's probably people listening to this that have been at work today or are at work today that have got drawings on the wall that represent the project. So, I'd be happy to wager on that somebody is sitting there looking at that type of view now. And it all stems from that, well, before the 90s, the 80s, 70s, the workflows that were paper-based from back in the day, as I like to say. And we've been talking about, or we've been hearing rumblings of paperless delivery. And what that really means, it does mean different things to different people, but it's a precursor to digital delivery, as we like to think about it now, and the processes that led to, say, the likes of PDF, but prior to that, the CAD files, the 2D CAD files. So we're kind of at this point where we're seeing model delivery taking place. Now, this is really driven, in my respects, many respects, from the desire for data-rich and data-centric models. Now, that really stemmed out of what I'd like to call that evolution from CAD through into the BIM era. And when you define BIM starting up, whether it's the mid 2000s or sort of post 2010, it gets a little bit vague. But BIM is an evolution on CAD and 3D. It's more than that. But what we're now starting to see is that evolution occurring again, that desire for much more data-centric and rich deliverables coming through, and that's driving digital twin. And that really takes us into this technology era again of cloud-based delivery and the Internet of Things. And this is where, again, we can provide some advantages with digital twins and the Bentley iTwin technology. So I just want to take a moment to look at that. Now, I'm sure you've all heard about digital twins. It's the latest industry buzzword, really. But it's totally warranted. It's all about these benefits of going digital and where we can advance in that. But it stems from four key areas of opportunity for adopting digital twin in the style of project delivery. It's about having that single source of truth for project delivery, where we're dealing with a mountain of data and models coming from a myriad of different data sources and incompatible systems very often. So the digital twin framework recognizes this diversity and pulls it together and provides a mechanism for harnessing and aligning and even normalizing all of that data to get it under control and accessible. And that's really where the digital twins provide us with an infrastructure to construct workflows and provide seamless, essentially 24/7 collaboration for stakeholders in the processes, globally even. And once we get that data and the process under control and all set up, we have a platform for making better decisions. So it's a decision-making platform. And potentially that can employ sort of AI and ML technologies that can then increase that productivity yet again and decision-making processes to define optimization and look for some sort of continuous improvement there. And ultimately, it's about a vastly improved capability to shorten project delivery times and lower costs and improve ROI. So again, going back to those project-wise quoted figures, that's where we're looking to try and increase on that return on investment. And we see that trend with year in infrastructure. So here we're just looking at the finalists that were from 2021 that were crediting the iTwin platform and essentially digital twin workflows, and some incredible projects there from around the world, from all corners of the world. So I'd encourage you to go and have a look at some of those projects and just see the capability and how people are pushing that technology to deliver on that. But it's really about trying to take, and some of the numbers that we're seeing out of these projects are, a 50% reduction in design time compared with, say, a 25% with just ProjectWise, and over a 40% reduction in errors and rework compared with 35% with ProjectWise. So increasing on the metrics that we saw just with ProjectWise by pushing that delivery further with digital twins. So let's take a look at digital twin workflows in a little bit deeper detail. So you've probably seen this type of slide before in terms of an infrastructure life cycle. And there's a lot of technology and tooling that sits in the different, I'm going to call them quadrants, but different areas in respect of that life cycle and the handoff of data that goes around. And it's really about, with digital twins, it's really about being able to leverage the information across these different digital workflows, whether it's the planning or the design engineering or construction or the O&M. It's having all of that data available. So owners, in particular, that you're doing work for, can achieve a higher rate of return on their investment, and also allow engineering firms and construction subcontractors to also perform at a higher degree and have access to the information just in time with the right information, and so that they are able to achieve higher margins and essentially win more work ultimately. So the digital twin that we're dealing with here for these digital workflows is representing that physical asset. So it's got to encompass the different disciplines and different data and the separate data that underpins it, that has to be brought together. And that's always a significant challenge in having a sort of a model-centric approach that glues it all together and provides the value for you. So what we're really doing here is taking people on this digital journey, using our existing data sources and pulling those together with current workflows, mapping engineering data and the like, and pulling those together with Azure-based cloud software that helps the designers, the builders, the operators, in that loop, that infinite loop cycle in infrastructure projects, to pull all of this information together so that they can actually access it, have improved decision making and reduced risk and clarity. And so concatenate that all together with spatial referencing, so that what we end up with is that digital twin representation with all of the information available to us that we can navigate down through, instead of that historic siloed information that we typically see in the past. So as I said, I come back to this slide, digital twin workflows. It's about having that physical asset that we're ultimately going to end up with, and a digital representation of that is concatenation of all of these different disciplines coming together and pulling that together and making it all available through these digital workflows. So how can we achieve this? This is where ProjectWise 365 addresses design delivery requirements across a wide variety of industry segments for engineering firms and owner-operators. It provides us with a detailed project-level digital review of designs in 3D and 2D and supporting documents, controls, and gives us insights into cross-discipline integrations that are all powered by Bentley's iTwin technology. And that allows increasing project demands for increasingly complex projects with what is a higher level of detail than we've ever seen before to be delivered on time and on budget. And as you expect from the name, ProjectWise 365 services integrate with and also extend the project design integration beyond the file-based management and publishing, providing us with an unprecedented project insights with issue resolution and data management necessary as you transition from traditional file approaches and through BIM processes to release the power and the potential that digital twin offers. So let's delve into some of those high-value propositions. So ProjectWise design review value proposition is all about that first step, project quality, and ensuring a high quality of projects using federated data built on digital twins that ensure infrastructure is sustainable and resilient and better serves all stakeholders. It's all about getting your intellectual property under control. It provides collaboration globally for 27 for your resources, so streamlines your delivery workflows and digital twin work sharing through the cloud and across your distributed teams. So it removes geographic and potentially technological barriers as well to ensure everyone has access and can share and leverage the project information through the digital twin and the communications that provides to the project team. It attempts to and it delivers on increasing your capacity to deliver. You've got to do more with less. That's something that we've seen has been a requirement over the last few years, and it's an increasing requirement as well. So enabling rapid project startup and project handovers is critical, giving people the access that they need. And that's really about future-proofing your ability to succeed. The industry is fast-paced, and you've got to maintain your margins across the board. And that's really what the digital twin technology is about, providing you more insights into your data, allowing you to review your best practices and look at the components that make up your project and streamline that and optimize those workflows. So where does this all start? Well, to me, it all starts with the model. We have to have a data-rich model. So we've got to increase the value in the model and the information that we provide that can be extended through the life cycle. So let's take a look at some of the paradigm that we offer here. It's about, in the design environment, adding additional information or attribution that we call item types into the model. Now, this can either be assigned at the creation time or as a post-process to come back and essentially mark up an attribute in the model and assign pay items into the model that is carried through the design process that can be visible. We can set up independent view queries to symbolize the display based on certain item types and properties. It allows us to generate reports that can be annotated into the model. And of course, all of this information that comes from the design application has to carry forward into the cloud environment, into ProjectWise 365 design review environment. So here we're in the same project, but we have the same model information and attribution available to us. We have presentation modes that are essentially engineering presentation modes. So the design geometry, the alignment information, the engineering presentation is preserved. We can look at and section very simply through the 3D model. So taking that federated model and take a slice through it, look at the attributed model, see the pavement constructions, see if we have potential problems coming through in that federated model. So it becomes a coordination environment with engineering tools and applications available to us. So here we can see that same pavement information with the same item type information carrying through, allowing it to be visible not just to the designer, but to a reviewer and for the contract team that is building up the contract. Web design collaboration is integral and essential. And this is where ProjectWise 365 Design Review provides us with that collaboration environment that combines from different data sources, GIS, mapping, terrain information, reality mesh information as well, so large-scale reality meshes, and the design data that's coming from different disciplines as well, pulling it into from different platforms into a single viewer. It provides a simple and easy to use interface, masking a lot of the complexities we see at the design level and at the project level, and providing some simple inspection and review tools that span the multidisciplinary processes that have to go on. But it still provides engineering intelligence and information. It's all done essentially through common CAD-like tools that measure and use saved views that we see in our design applications, but combining it into an interface where we can use Microsoft Teams to benefit from greater connectivity. It draws on issue resolution capability. Let's take a look at that. There it is. So it allows us to, in the cloud environment, create issues, associate those to as work items back through to an individual user, and provide seamless operation with ProjectWise back into the design environment. So we can hand that design change, those issues back into the design, collaborate, and so what we have here is a full 3D markup, review, capture, location, assignment, and tracking for all of these multidisciplinary collaborative workflows. It provides us with a dashboard level access as well to monitor the status and the progress of these issues throughout the project. So we all know that the clash detection is a significant area of work that we have to undertake. And a key aspect and benefit of BIM is and federated workflows is that ProjectWise 365 extends this capability further with customizable and rule-driven model data validation processes that can be automated, and that's a key aspect to provide that real-time insight into the project and coordination in that project for, say, clash detection and data checking, and drilling down into attribution in the model to validate that we have the right information available and to streamline investigations that we may need to do manually. So another interesting area that we can take advantage of is with version compare. And this really stems from the ability with iTwins to provide a timeline of change and traceability and an audit trail for that changelog history. So it means we can go in and identify when something changed and look at these side-by-side comparisons to identify graphical differences. When did this culvert appear, or when did we get this clash coming in? So we can trace these things back, add sort of visualization data and attributes, and tie that in with issue resolution service so that we can actually start to really extend the capability for the project reviewer. So we've talked about ProjectWise 365 and what that provides, but this session is about civil and civil integration and how does that help us? So this is where what we've been working on is adding industry-specific validation capability to Progress ProjectWise 365. So extending that capability based on our pedigree with the likes of Open Roads, Open Rail, and Open Bridge to provide civil-specific tools. And during this time, we've been running some early access into some of the tools that we've seen, and even the sectioning, the profiling, some of the view decorators, the annotation that we've seen have all come from the civil teams, and some from great work that the civil team has actually done and put into that. And a great quote here from one of the early access sort of participants, Chris Andrew at AECOM, and where he basically says, we're not aware of any other tool that allows a review of alignment for road and rail without the need for design software. That's a key aspect, without the need for design software. For the likes of looking at profiles and reporting that are being provided here with these tools. So let's take a little bit of a deeper dive. Now, I do need to call out a disclaimer here that release plans and timelines are forward-looking estimates, projections only. There can be no assurance that Bentley will be able to meet such estimates or projections by the date specified or at all, and do not make any purchase decisions based on forward-looking roadmaps. So what we're going to look at now is some futures. What are we working on? It's quite exciting times again. And this is where I'd like to sort of open up and invite people to join up to take a look at what we're about to look at. So extending ProjectWise 365 further with civil design validation capability. So we will put the sign-up web address. You can scan that QR code, and there's a web form. It's just a very simple form to fill out just to sign up, because we're going to have to give you access to some project data, and it'll just be using your standard Bentley login to get access to that. So I'll show that again at the end once we've demonstrated some of the capability. So what have we been working on over and above the standard tools that we saw with projects, with the profiles, with cross-section and the likes that we saw in the standard ProjectWise 365? Well, this is where we've been focusing on the QA, QC and model validation. Now, the reason we've focused here is because of the gap between the design environment, where we have all of these design tools and complex design tools, and the drawing environment, where we perhaps do that review, the project handover. And how can we provide tools that simulate some of the workflows we might do in the 2D, but provide value and make them simple to use? And so this is where we've been extending some of the capability. So we're going to take a look at some of these in a little bit more detail. And extending the tooling that we have, we've been working sort of further and taking that further. We've already seen the cross sections, but extending that to time with the civil workflows to provide more intelligent navigation. Look at object clearances and provide sort of things like contextual text in 3D and whatever. So we're going to do a deeper dive here into some of these tools that you're going to see in the EAP. So one of the first tools that most people seem to want to play with is the drive. It's nice and easy to use. It's very visual and allows you to jump straight in and see what's going on. So it provides some basic line of sight sort of tracking and driving through the geometry, looking at the surface, interrogating that surface. We can get a tracking mode with a preview of where we are, an overview, can combine it with reality model, and obviously that's got to stream in and load the level of detail, and also add in some simple targets, potentially for visibility and checking and tracking. Can we see these targets in the distance? And if we can't achieve the targets, obviously we can track and stop that, and then drop out and do some measurements associated with that to understand why we can't achieve that. Another tool that we've provided is the ability to drill down into the civil geometry itself. Now, that may not be geometry that Open Roads has provided or Open Rail. That could be geometry that has been provided via a third-party application. And so with this, we provide a validation service that allows us to go in and look at the individual geometry and track and store the results for that geometry to identify where there are potential deficiencies, looking at the speeds associated curve lengths. Have we got sufficient curve length or inadequate curvature or length of elements within the project? So we can identify areas that we may need to drill deeper down into and identify problems that we want the designer to come back and qualify or make changes. And so we can tie that in with issue resolution service and send that back to the designer. Another area that we focused on that really starts to provide a new capability is with super elevation analysis. And so what we've provided here is a means of running analysis and storing that analysis to be able to recall, navigate through. And this doesn't have to be off a Bentley solution. We can interrogate surfaces relative to geometry and extract essentially the super elevation and navigate down the critical sections where we have changes in the surface crossfall and open up the cross-section view and navigate down to validate that the super elevation has been applied and look at potential problems within the model. Now the view decorators that we can see in the plan view and the colorization indicating the crossfalls are all visible through into the drive applications as well. As we're doing that investigation for super elevation, there may be areas of detailed interest that we need to drill into. So potentially in the area of, say, ADA ramps, and we might want to drill down and look at those specific areas in detail. And so this is where providing a point analysis tool that allows us a tracking capability similar to what we have in ORD with point analysis, tracking at that point, looking at the location, looking at the slope vector on a surface or on an element, and being able to stamp that into the model. So as we get into an ADA ramp, we can look and are we achieving the slope that we need for the ADA ramp? Does it fall within the criteria that we need to achieve, and stamp this in so it's available and visible that we've actually investigated this. And probably it ties in with clash detection, but clearance checks are critical to what we do, but actually in a 3D model are typically quite hard to achieve as well. And how can we drill down to achieve the clearance checks that we need, looking between the complex models that we have. So, this is where, again, a stored analysis can provide value. We can create these clearance checks and store these clearance checks to be able to recall and reuse. If it's coming from an intelligent design system, say coming from Open Bridge Designer, we can understand the bridge object itself. So we can pick the bridge object and pick the road surface and look to achieve a certain clearance at that location. Are we achieving that? If we're not, then we can color code that as a red clearance. We've got a failure there. If we've got a positive clearance and we're achieving, then we can drill that down and represent that as a green clearance that we're okay. For the minimum clearance we provide, you can jump straight into that cross-section view. So you've got access to more measurement tools to validate the results that you're getting with the simple measure tools that we provide. Now, here we're looking at a lateral clearance, a minimum 3D clearance. So we're in drive mode. We've identified potentially a problem that we might be looking at, but we can pause the drive mode and actually go into a 3D clearance and do some more validation in there as well. So lots of clearance checks that you may well need to run in a typical model validation situation. Now, there's lots more tooling to come that we're working on and bringing to delivery. But as I've said, EAP. So again, I just wanted to draw out this EAP access. If you would like to participate, we would love you to participate. Here is a QR code and a web link to a form to fill out essentially your name, contact details, so that we can reach out to you and give you the appropriate access to get in with these tools. So I would love for you to participate and start to see the value that digital twins can provide. So I'd like to finish on a little bit of a summary as to what we've seen with digital twins and the workflows. And it's all about that improved collaboration amongst stakeholders, bridging the gap between the design environment and the review environment, and then obviously into construction and bid processes as well. Handing that data over in a reliable way with all of the data fidelity, so not dealing with the siloed handoff of information that we typically see in the past and historically have seen, trying to carry that information forward. So as I said, it all starts with intelligent models and essentially increased level of detail coming through and carrying through in those processes reduces the risks, ultimately giving fewer errors, potentially fewer emissions. Now, you're still going to have to deal with 2D sample details that you might want to include. I mean, an ADA ramp is a good example. I might want to locate an ADA ramp. Do I need to design every ADA ramp? Well, the answer to that is possibly not, but we still get value if we did. We can go and interrogate and look, are we actually achieving the slope values, the maximum slope values that we are allowable for an ADA ramp? So increasing the level of detail and modeling detail, can provide greater insights into the project. I've put there as well, elimination of 2D drawings. It's not about that. It's augmenting the 2D drawings. We know 2D drawings need to exist and are going to be there for some time. We look at the consumption of those and what they're used for. Not everybody's ready to accept a 3D world, so we've got to incorporate that and into the workflows and make it accessible, just as accessible as it is in the 2D world, so that we have the information available. And that's really comes down to making use of that common data environment, that model information, that rich data environment that's provided there, and ultimately enhancing that design through to construction quality so that we get that reduced risk, reduced costs, increased or reduced delivery times, and ultimately operations and maintenance benefits on the back end. Hopefully that's giving you some insight into digital twins and civil workflows. Exciting times, as I said earlier on, and I look forward to your participation in the early access program, and we'll be following this up with more information about the early access program and ultimately release of this capability with ProjectWise 365. Thank you very much.